Lesson 6. Last lesson in this unit. And we get to talk about L'Hopital's rule. Okay? More commonly mispronounced as La Hospital. But it is not La Hospital. It is pronounced L'Hopital. And let's see, do they have...
What?
So...
Low. What's the origin of the name?
German or French?
I was thinking
seems
French because it's
The L makes me think French. But anyway, so you will also see it spelled like that, thus lending itself more to L'Hopital. Okay. Okay, so these are both equivalent spellings. She chooses to use the one that's La Hospitals. However, you won't hear me say La Hospitals. It's L'Hopital. It's a name. It's a person. Okay, so it's named after a person, if I recall correctly. Okay, so now I have referenced L'Hopital's rule earlier this year. Okay, we're gonna go back and review Unit 1 right now, or Unit 1 and 2, because we're gonna do some limits. But we have to use derivatives to find these limits. Okay, so here's the deal. L'Hopital's rule is a great tool for finding limits that are often difficult to evaluate. Give L'Hopital a chance, okay? I promise. I like L'Hopital, and I think you guys will too. Okay? I'm not saying that in joking. I think you will. You're gonna laugh at me, but okay. It can help with determining limits at infinity or asymptotic behavior. Use it for curve sketching in the next section as well. Okay. When evaluating limits by direct substitution, there are 7 expressions known as indeterminate form. And we're going to focus on a couple. I would say the big ones we're going to focus on today, I'm trying to remember how far this lesson goes. 0 over 0 and infinity over infinity. Those are the big ones. Those are your big indeterminate forms where when we get 0 over 0, I always say, okay, that's not an answer. That's not 0. That's not undefined. Okay, it's not your limit does not exist. It just means we don't know. Okay, we don't have the right information here, and we have to pick a different method. So indeterminate, when you get an indeterminate form, as I said, specifically 0 over 0, infinity divided by infinity. L'Hopital gives us another option here. Now, there's also 0 times infinity, 1 to the infinity, 0 to the 0, infinity minus infinity, or infinity to the 0. As I said, we don't really work with most of those others a whole lot. Okay, at Calc 1 level, it's usually the first 2. So, consider the limit of a quotient. So, when you have a limit of a fraction, as x approaches c of f of x over g of x, L'Hopital's rule states that when f of x over g of x has an indeterminate form of 0 over 0 or infinity over infinity, then we can replace f of x and g of x with their derivatives. And I'm not talking about doing quotient rule, just derivative of the top, derivative of the bottom. And then we can redo the limit is what happens here. Okay, so I know this page, we need to get to examples to really make it make sense. But let me kind of go through this. Assume f and g are differentiable on an open interval containing c. Also assume g prime does not equal 0, so your denominator does not equal 0. Then, okay, if the limit of f equals 0 and the limit of g equals 0, and this is something we'll talk about how to state, then this limit of f over g is equivalent to the limit of f prime over g prime. That's your basic stating of L'Hopital. It also holds true of infinity over infinity. Now, a couple of things. In order to be able to use L'Hopital's rule, certain conditions have to be met. If your denominator is 0, of the derivative of the denominator is 0, then the limit is undefined. No oscillating functions. As x approaches c, the limit must approach a single y value. And so bottom one, the limit cannot equal plus or minus infinity, okay? we have to look at one or the other, or it's just undefined. So if you've got limits going both ways, it's undefined there. So again, we'll make this make sense. Okay, here we go. Let's go to the next page. That's what we really need to do. So, in order to use L'Hopital's rule on the AP Calculus exam, students should show proper procedural steps and notation. To master this process, be sure to explicitly show the limit of the numerator is 0 or infinity. And I'm going to demonstrate this. Show the limit of the denominator is 0 or infinity, or negative infinity, I guess. 3, you may want to state that the limit is indeterminate form. 4, by L'Hopital's rule, we'll write out the limit. And then 5, we'll find the limit using proper limit notation. So, let's look at example 1. Because right now you guys are saying, I have no idea what you're talking about, Mrs. Sargent. I don't believe you that I'm going to like this. So, okay. As you go through this, how would you think about finding this limit? I know, I'm asking you to go back to the beginning of the year. Plug in 5. That's our go-to method, right?
It already doesn't work.
Okay. Plug in 5. Well, 5 minus 5 on the bottom is 0. It's okay if you only have 0 on bottom. But, what, 25 times 2 is 50. 50 minus 45 minus 5, guess what? We just got 0 over 0. Okay? We talked about some other options back at the beginning of the year. L'Hopital's fits those other options pieces. Now, to be official, okay, I'm going to kind of go through step 1 to, kind of like what she has. So step 1, to be official, before we can actually use L'Hopital's, is we need to state that the limit as x approaches 5 of the, in this case, let's just do numerator, minus 2x squared minus 9x minus 5. And what did that limit equal? 0. And then we also need to do the same for denominator. So the limit as x approaches 5, whoops, of what is it? X minus 5 equals 0. You don't have to show your work there. This is calc. They assume you plugged it in your brain and you got 0. Okay? Now, I guess she has this numbered. That's kind of your step 1. I guess she doesn't have them. She is this kind of combined, I guess, so to speak. Because we're getting 0 over 0 here, what we know is this is an indeterminate form. And so for my step 2, or my response 2, I'm going to say indeterminate form by L'Hopital's. And my indeterminate form in this case was 0 over 0. Somehow I've managed never to fall on my face while up here teaching.
It's fine. Okay.
Let's keep it that way. I've tripped a lot, like what I just did there, like my feet get tangled on these things, but okay. So right there, I've just kind of basically stated, okay, I got 0 over 0. That's an indeterminate form. That now gives me permission to use L'Hopital's rule. So I'm going to go ahead and write out, and we could do this a couple different ways. You'll shortcut it once you get into it, I know, but the original limit, the limit as x approaches 5 of 2x squared minus 9x minus 5 over x minus 5 is going to be equal to. And it's going to be the limit, and so it's still going to be the limit as x approaches 5. Now, because we're using L'Hopital's, take the derivative of the numerator. What is the derivative of the numerator?
4x minus 9 minus 9.
Take the derivative of the denominator. 1. So this original limit that had an indeterminate form of 0 over 0, take the derivative of the top and the bottom, and that's my new limit to evaluate.
So we don't have to put prime marker or anything?
Not this way that we're showing it.
Then can't
Okay.
you just put limit as x approaches 5 is 4x minus 9?
And yes, you can. Okay. And so step 4 is essentially finding the limit. And if I'm essentially finding the limit, which you could really just go on to from where you're at, but it's the limit as x approaches 5 of 4x minus 9. What are you going to do to actually find the limit?
35.
Plug in 5.
11.
Okay.
Yeah.
And so you can show this work or you cannot. 4 times 5 minus 9 is 11. Okay. And you're done.
That's just a lot more time.
Now, it's okay. So here's the deal. The process itself is a lot quicker if you're not writing out all the formal details. And there's a time and a place, and I don't know how often you would actually see it where you'd have to write all the formal details out on the AP, because multiple choice, they don't grade your work. It would be when, you know, if L'Hopital came up and open-ended a, what do I want to say, free response question, is when you'd actually have to write it out. Now, technically, did we have to use L'Hopitals on this problem?
No, we could have done whatever you're supposed to do. What we were doing.
So, what was I going to say?
Exactly. I have no idea.
So, when plugging in failed, what were some of the other options? Do you remember any of them?
Factoring.
Factoring. Does that numerator factor?
Yeah.
Guess what? It does. That 2x squared minus 9x minus 5. 2x squared can break into 2x and x. 5 is going to have to be 5 times 1. I can see that I need a 9 in the middle, so I set it up to have 10x and 1x. I want negative 10x and plus 1x. Hey, guess what happens here?
X cancel.
The x minus 5's cancel, and so this is also the same as doing the limit as x approaches 5 of
2x plus 1.
plug in 5. What do you get?
11.
Same answer?
That's so crazy.
Okay. Now, why did I take my time to show you that? I'm just trying to show you it works. Okay? That's what I'm trying to show you, is it works, it's equivalent, it's good. Okay? Now, here's the deal. Will everything we do always have that alternative where it can factor? No. Most of the time they won't factor. That's why you go to L'Hopitals, because factoring isn't an option. This one just happened to have been able to factor. I'm going to say, or could have factored. So,
Math is just mind-blowing with me.
my proof is that it would have worked, okay? Now, okay. For instance, ready for number 2?
I've already started.
I know. We're behind Sophie here. Okay.
I was like, I understand this.
Okay, so first of all, do I need to use L'Hopitals? Don't always just assume.
Yes.
Negative 5 plus 5 is 0. 4 minus negative 5 is 9.
3.
Square root of 9 is 3. 3 minus 3 is 0. Do I need to use something? Yeah. I got 0 over 0. L'Hopital is an option. Is factoring an option on this one?
No.
No. Your option on this one, if we're not going to use L'Hopitals, would probably be multiplying the top and bottom by the conjugate of the top.
That's not.
L'Hopitals is going to be much better. So, okay. First of all, I'm going to state, to get an AP form, I'm going to state each of my limits separately real quick. And I'll try and be a little less detailed this time. Limit as x approaches negative 5 of square root of 4 minus x minus 3 is equal to what? 0. The limit as x approaches negative 5 of x plus 5 is 0. And what I kind of did right here then is I kind of said, okay, because of this, what do we know? This is an indeterminate form. And if it's an indeterminate form, we can use L'Hopitals, right? Or I guess I just wrote indeterminate by L'Hopitals rule. However you want to write it. That didn't work. Okay. So, my original limit. The limit as x approaches negative 5 of square root of 4 minus x minus 3 over x plus 5 is going to be equal to the limit as x approaches 5.
1/2 4 minus x to the negative 1/2
It is.
over 1.
Okay, so derivative of the square root of something. Remember, square root is a power of 1/2, so put the 1/2 out front. Keep the 4 minus x. 1/2 minus 1 is negative 1/2. Now, did Sophie say it?
I didn't. But don't you just, isn't it just multiplied by 1?
Times the derivative of the inside. What's the derivative of 4 minus x?
Negative 1.
Now, I can, are you guys okay if I just tack the negative on to the 1/2? I mean, or it's put tacky, I mean, you can write it like that. Or what the official, I mean, you can just say, oh, times negative. Is there what you have? Okay, minus 3, that's going to be a derivative of 0. Derivative of the denominator. 1.
So it's 1 over 2.
Okay.
What about the minus 3?
Now, if you want to clean this up some, which I would, maybe you guys don't. My brain needs to see it better. Where's a negative power go?
So then it's negative 1.
Negative 1 over 2 times the square root of
4 minus x.
Negative 1/6.
I haven't gotten that far yet.
That's my
negative
shout
1/6.
out. Even though
So,
This is so low.
if you plug in the negative 5, technically I did another line of work on my paper, but so negative 1 over 2 square root of 9, negative 1/6.
yes. I first had 1/6 because I forgot the negative.
That's all it is. So yeah.
Wow.
I'm really good at this.
I believe you got 1/6.
Now, minus the annoying the amount that we write out. L'Hopital's itself. Are you seeing that it's pretty easy?
Yes.
Okay. In all honesty, if you're just doing something quick and easy on your own, are you going to write all of this out? No, I'll be honest. I would probably just jump in. If I'm doing this on my own, I might kind of be like, okay, and this is unofficial notation. My brain's saying, oh, it's 0 over 0. So then I would probably just jump in right there, is what I would probably do. Now, is that official notation that's going to make AP happy? No. But is that the basics of what you need to do? Yeah.
We don't even care about notation. It's what we- If
So.
we show that we know it, why don't they just let us do it?
That's not how it is.
Okay. Example 3. Ready?
So infinity over infinity.
I don't know. What is it?
Yeah.
So,
I don't know what to do.
okay, so if we plug in negative infinity. So on top, negative infinity squared. Well, first of all, negative times a negative is going to be a positive. If you're multiplying infinity times infinity, that's just infinity. Okay, so the top is infinity. The denominator, e to the negative of negative infinity.
Positive.
So that's e to the positive infinity,
So it's just infinite.
which is e raised to some huge power. It's infinite. It's growing bigger and bigger and bigger. So yes, this is an infinity over infinity one. So now for L'Hopital's, that means when I'm stating this, the limit as x approaches negative infinity of x squared is infinity. The limit as x approaches negative infinity of e to the negative x is infinity. Okay, so this is our indeterminate form. And our indeterminate form says we get to use L'Hopital's. Okay. And again, if you want to throw that infinity over infinity in there so you remember, that's fine. Okay, so the limit as x approaches negative infinity of x squared over e to the negative x. So we're going to take the derivatives here, yes? What's the derivative of x squared?
2x.
What's the derivative of e to the negative x?
E to the negative
X times negative.
So derivative of e to some power is e to some power times the derivative of the power. What's the derivative of negative x?
Negative 1.
So I personally, kind of like how earlier I put the negative in front of the 1/2. Common, once you're used to this stuff, and you can do the chain rule pretty easily, is to put the negative out front. Okay. 2 times negative infinity.
Negative 2 infinity.
Negative infinity. Divided by negative e to the negative of negative infinity.
Negative e to the infinity.
Negative e to the infinity.
So infinity.
It's negative infinity.
Technically negative infinity.
So it's changed.
So we went from the indeterminate form of infinity over infinity to
And it's
negative infinity to negative infinity, which is yet essentially another indeterminate form. So guess what?
repeated use
We get to go through L'Hopital's rule
again.
time 2. In other words, you can, if you go from one indeterminate form and you get indeterminate form again, you can repeatedly use L'Hopital's rule. This time there's going to be a difference. Okay? Twice is all it's going to take on this one.
Is there any bar that takes more than twice?
It could take more than twice. I don't know if we have any like that, but okay. So, my unofficial brain is kind of thinking, okay, I just got negative infinity over negative infinity. Now, officially, what should you be stating here? The limit as x approaches negative infinity of, this time it's 2x is equal to negative infinity. The limit as x approaches negative infinity of e to negative x is negative infinity.
Would it be negative?
Yeah. Too many negatives. I'm getting lost. So now we have another indeterminate, which is going to allow us to do L'Hopital's again. So now, our most recent form was the limit as x approaches negative infinity of 2x over negative e to the negative x. So it's still going to be the limit as x approaches negative infinity.
2.
Derivative of 2x is 2.
Over e to the negative.
Derivative of negative e to the negative x. Well, the derivative of e to some power is e to some power times
Negative 1.
the derivative of negative x, which is negative 1,
Which is just
times the negative that's already out there. So that's going to make it back to positive e to the negative x. Now, what's the deal that makes the difference this time?
there's no
It's 2. Is it constant?
there's
The derivative, or the limit of 2 as x approaches negative infinity.
2.
That's 2. So we know we're not going to have an indeterminate form now. I'm not getting 0 over 0. I'm not getting infinity over infinity or negative over negative.
2.
I'm getting 2 over something.
2 over infinity.
So e to negative x, plug in negative infinity. So e to the positive infinity, which is going to be positive infinity. Now, so think about this concept. Remember, infinity is not a number.
0.
Okay? This is, you have this small set number of 2 over a denominator that is getting bigger and bigger and bigger and bigger. So this is saying, like, okay, what's happening to the value of, say it's 2/3, and then it's 2 100ths, and then it's 2 1,000ths,
Closer to 0.
to 1 millionths. my decimal is getting smaller and smaller and smaller and getting closer and closer to 0. Okay, so I think this is 2 divided by basically, just trying to 2 over an increasingly larger number. So if you think limit behavior, which is basically what we're trying to think here, then this is going to equal 0. Okay? So basically what I'm saying is some number divided by infinity is always going to be 0. Okay?
We actually got a lot done.
Not really.
Yes and no, right? Yes and no.
I mean, we did homework questions and
We did.
That's out of our usual.
So, okay.
We can start with it.
You could probably start some homework, yeah. I don't see why not. I don't have the answer key out there. I will say, when I start off with number 4 tomorrow, a trick for AP notation is that, because notice, writing this stuff out, I'm going to have to write that top equation out and that bottom equation out multiple times, yes? An AP trick is, okay, if I define my top equation to be f of x, like if I go ahead and just list this, f of x is this, and g of x is this, I don't have to keep rewriting every time this whole big equation. I can just refer to it as f of x and g of x. It's an AP trick, okay? And if Sophie, if you've started, you've seen where that would be useful.
Yeah.
Okay, so that does give you an option there. So, okay, tomorrow you can start that one when we get in
I'll do
class.
email.
I don't
You can't believe.
Why don't I do the homework? Do you